An inverse function is is a function where the dependent and independent variables of the first function are interchanged for an appropriate set of values of the dependent variable to create a new function. So basically an inverse function means you switch x and y. So to find the inverse of something, you switch x and y. So, remember that inverse notation, if this is the original, the inverse has the weird little -1 on it. So this means the inverse of f of x.
So what if you did the inverse of the inverse? Would that be -2?
The inverse of the inverse would just get you back to the original. Because you're just switching x and y, so if you switch x and y again, you're back to the beginning. No, that wasn't a bad question. Oh, what?
I don't know if it's just me, but the original looks like it's spelled on-ginal.
It does.
It does, because my R and I are connected. Anyways, so first of all, is this exponential? Raise your hand and tell me if this is exponential.
What does that mean again?
It means it's a constant multiplication.
Oh, yeah.
What?
Oh, yeah.
What are we
Dividing.
Raise your hand. What are we multiplying by every single time? Connor.
Negative.
1/3.
So if you think in your head, you cannot say it out loud, but if you think in your head, you're dividing by 3, which is what almost came out of your mouth, which I don't want you guys to say dividing by 3. Remember, to find the multiplication, you put 1 over that number, okay? So it's 1/3. So raise your hand and tell me, is that exponential growth or decay?
Decay.
Decay, thank you. So to find the inverse, we switch x and y. So Grace, -527 becomes?
27.
Tanari, -49 becomes?
Where?
-49, the second row.
Okay, isn't it 9 -4?
Yes. Alyssa, -33 becomes?
3 -3.
Jordan, -21 becomes? Sorry.
1
Lane. The last one becomes? So, look at what we did. Stop, guys. Look at what we did on each one. So we're on -1, 1/3. What would that become? Yes. Okay. So again, raise your hand and tell me, is this exponential or not, and why do you know? Is that exponential or not, and why do you know? Lexi.
Yes, because it's multiplying by 4. Wait, no, 2.
Okay, it's multiplying by 2 each time, which makes it exponential. Raise your hand and tell me, is that growth or decay if it's multiplying by 2? Riley. Growth, the number's bigger than 1, right? So, Emma, what's the inverse of -2 for?
4 -2.
Yes. Brian, how about of -1, 8?
8, -1.
Connor Clover, the next one there.
16, sorry.
Justin Crater.
32, 1.
Cassie. Okay, so questions on finding the inverse from a table before we move on to the next one.
Oh, that's all we're doing.
We're going to graph them and talk about how the asymptote changes, but besides that, basically.
I thought this would be.
All right. So it says graph the inverse of the function on the same graph and label the inverse. So we have the original. So we're going to take the original, which I think is called b of x, right? And we are going to put it on in a table. So I'm just going to start at -1, and I have -1, 4, 0, 1. And I'm going to say that's probably 1, 1/4 there, and then that's all I can see. So I'm going to stop there, and we're going to make a table for the inverse. Now, before we start here, is this growth or decay, and how did you figure that one out? Is this growth or decay, and how did you figure that one out, Connor?
Okay.
And what did you look at to determine decay?
It's that mixed backwards.
The backwards J, the graph, it looks like an L or a backwards J, right? So the graph tells us that. What is the decay factor? What is my decay factor on this one? What is the decay factor, Kaylee?
1/4.
It's multiplying by 1/4, right? Think division in your head, but don't say it out loud. Multiplying by 1/4. Okay, so what would my inverse table look like, RC? Tell me the whole entire table. What would the inverse table look like?
4, -1, 1, 0, and 1, 4, 1.
Good. So we're going to then plot that. But before we plot that, first of all, what do you guys think the asymptote is here? What do you think the equation for the asymptote is here, Jana?
0.
For b of x. It's at 0, right? So we think it's y equals 0. Do you think the asymptote is going to stay in the same place if we switch x and y?
Yes.
No. Yes.
No, because you're switching x and y. So if you switch x and y, what do you think the y is going to become for the inverse of the, or for the asymptote of the other one? Yeah.
1.
If you switch x and y, what would y become?
Negative.
Switch x with y, switch y with x.
0 equals 1.
Switch x with y.
X equals
Yes, thank you. Our asymptote is going to be at x equals 0 because you switch x and y.
what's going on?
Okay, so if you switch x with y, that's what the inverse means, Connor. Okay? So I literally changed x, switched y here, into a x. So x equals our vertical lines. So we're going to have an asymptote here for our inverse. And then we're going to plot the points. So I have 4, -1, 1, 0, and 1/4, comma 1. Inverse is a flipping of the ordered pair. All right, so what do you guys, which line do you guys remember the inverse graphs being reflected over? Which line was the inverse reflected over? Does anybody? Y equals x. The line y equals x is your reflection line. So y equals x is this line here. So, sorry, that did not turn out right. So y equals x is this line here. So this is b inverse of x, and this is y equals x. But if you were to fold your piece of paper over, do you see how these points would then line up? So it's a reflection over that line. So if you're reflecting over y equals x, that's why the asymptote also switches to an x equals. All right, let's look at the next one. Questions there so far? Questions there? All right, so it says graph m of x equals 1/3 x and its inverse on the same graph and label. So first of all, you guys know how to do 1/3 x in the calculator, so start typing in with a -2 and a -1, a 0, 1, and 2. You're using this equation in this table to figure out the points for that.
So you just do like 1/3 -2 again?
To the -2, yeah.
Okay.
And fill in that table. Maybe it's the user.
No, what do you know?
Get right.
It's 9, right?
No.
Do you have your own? What happened to it?
I lost it in my backpack.
Do you think it's still in there?
Eat it.
So 1, ABC 3 makes it a fraction, and that raises it to a power, so
right.
-2 there.
No, not.
Okay?
I do this room, Freddie.
Yep. The first part looks good. It's easier.
No, I'm not even. No.
All right. Please pay attention. Did anybody not get the numbers that I just got up on the board?
I'm not done yet.
Keep trying, Connor, and let me know. Does anybody not get the numbers and you need to help them because they have no clue how to use the calculator? See, it's just torture you with that one until you actually take the time to look for your calculator. All right. What is the equation? What is the equation of my asymptote for this line here? What is the equation of the asymptote, Mike, for m of x equals 1/3 to the x power? That's not an equation. Yes, it's y equals 0. So there's nothing added at the end here, so it's at y equals 0. So we're going to graph that. So Lamar, what would my inverse table look like then? If it's -2, 9 here, what would this become? The signs don't switch, just switch x and y. So switch x with y.
9,
Okay, next one.
3, -1,
Okay,
1, 0,
good.
1, 3, 1,
And?
1, 9, 2.
Okay. And what would my equation for my asymptote be for the inverse? What would the equation be, Jordan? X equals 0. We just change out that y equals for an x equals. So I graph my asymptote after I've labeled this graph that I never labeled. So make sure you label your graph m of x, and then we're going to graph our other one. My asymptote is the vertical line that I'm not drawing very straight. So that's the asymptote there, and then you're going to plot your points. All right, so looking at that, did you graph both of them on there? Did you cross your asymptote? Did you cross your vertical asymptote?
Yeah, but I drew
You haven't drawn.
bad.
You haven't drawn. You haven't even done the.
I'm tired.
You crossed the asymptote.
Okay,
No, you didn't. No, you
excuse
didn't.
me.
It's hard to see because there's two
Yes.
things on there. Okay, make sure, guys. Make sure your inverse is not crossing over that vertical asymptote. Did you have a question? Jordan, or you just just like that? Okay. All right, questions there before we get the homework out?
That's it?
We have one more. Okay, before we move on, is this exponential growth or decay?
Okay.
Decay. It's the 1/3 is between 0 and 1. Good. Okay.
Yeah, that was
Okay, fill in your table. H of x is 1/4 x, or 1/4 times 2 to the x. I know, I have seen both calculators. I'm fully aware.
That's a very different game.
Oh my gosh.
Connor, what are you talking
Okay, guys, stop talking.
Wait, what do we do with the 2? Oh yeah, never mind, I forgot. I got it.
Are you sure?
Yeah, you put it in the parentheses, right?
Yeah, now raise it to the power. Okay, you guys should be filling out your tables, please. I'm going to come around, Lamar. I just took the longest way there, I
I
think.
got a crack. Ew.
What's up? You did that? Yeah. No, you do second PRB. There you go. Okay, guys. Head should be up, and you should be filling out the table.
Yay, I did it.
So Emma, where is my asymptote for that line? Or that exponential, sorry. It is at y equals 0. So we know we're adding 0. So we have an asymptote at y equals 0, and we're going to plot our points. Which are crazy, because they're tiny. And then we're going to label it. Okay, Connor Clover.
Yes.
What is the asymptote for my inverse?
0.
What equals 0?
X.
X equals, it switches X and Y. So it's X equals 0. Colin, give me the table for the inverse.
The whole thing?
Yes, please.
Okay, so let's see. For x on the first one, you have 1/16, and then for the inverse, or well, not the inverse, for y, -2, and then the next one is 1/8, and then -1, and then 1/4 and 0, and then 1/2 and 1, oh, I thought I was reading the wrong one for a second, and then 1 and 2.
So we have our vertical asymptote here that we cannot cross.
Oh, I forgot. I drew my line the wrong way.
That genius.
And this is h inverse of x. So is this original an exponential growth or decay function?
It is
Growth.
growth.
Look at the 2, not the 1/4. It is growth. Okay. So let's